we are going to talk about oxygen references. Now, the concept of oxygen references is really important when it comes to stack testing, and their purpose is to reverse the effect of pollutant dilution. So let's think of an example. Let's say that we have a coal-fired boiler, and in this coal-fired boiler stack, there is a concentration of particulate matter of 200 milligrams per normal cubic meter. If ambient air is introduced into that stack, whether on purpose or just as a virtue of how the process works, that means that that concentration is going to be diluted by the ambient air. And we need a way that we can reverse the effect of that dilution so that we can compare that stack that has pollutant dilution with another stack that doesn't have dilution. And the way we do that is using oxygen references. Now, to apply an oxygen reference, we multiply the concentration of the pollutant by an oxygen reference factor. That factor is 21 minus your oxygen reference divided by 21 minus the oxygen that you measure in the stack. So oxygen references are always specified in the legislation. So for a coal-fired boiler, the specified oxygen reference would be 10. So we can insert that into our equation. The bottom of this equation needs the oxygen concentration that is measured in the stack inserted. Now keep in mind that ambient air contains 21% oxygen, and 10% is sort of the typical oxygen concentration that you would expect directly downstream of a coal-fired boiler before any ambient air has been added. If ambient air has been added, your concentration of oxygen will be higher than 10. Let's, for example, say that the concentration is 18 equals 3.6. Now what that means is every time that a stack has an oxygen concentration of 18%, it means that we're going to multiply the pollutant concentration by this factor of 3.6. And so the effect of dilution is going to be reversed because we're going to be multiplying it by this factor that's greater than 1 and basically making it bigger and correcting it back to what it should have been. Oxygen references also work the other way around. So say for some reason the boiler is operating incorrectly and we are only measuring an oxygen concentration of 5%. What happens to this factor is it becomes less than 1. And so we will then be multiplying the pollutant emissions by a factor less than 1, which will make them smaller. And once again, just be correcting them so that they are representative of what's actually happening in the process and can be compared on a like-for-like basis with other stacks. Something that is really important to know is that oxygen references can only be used in situations where combustion is taking place. So in combustion, oxygen is consumed and the concentration of oxygen goes from 21% to a number lower than 21%. If you have a process that is happening at ambient conditions, so no combustion is happening, you will be measuring an oxygen concentration of 21% downstream of the process. And what's going to happen when you put that into your equation is that the bottom of your equation becomes 0. And we know that we can't divide by 0. So, in summary, oxygen references are used to reverse the effect of pollutant dilution and make results comparable between the stacks. And they can only be used when combustion is taking place, and they cannot be used in ambient situations.